Hi everyone, my name is Nick Burton. The only introduction I'll give you is I'm a computer science student at RMIT. Anything more than that you can find out if we have a chat at the bar. I'll get straight into this presentation, which is actually the third time now I've done this, and it sort of says two things to me. One, that there's a lot of interest, a lot of developer interest in Android, and the other thing it says is that I'm going to have to stop peddling this introduction and actually do a more advanced one for people who are ready to start getting and really do some coding. So today is really sort of more the high level stuff. We'll focus on, have a look at the software stack and also the application components, and then we'll go from there. Okay, so yeah, so today's really going to be on what Android is and actually show you what it looks like, because I imagine that some of you, from the hands up before, you haven't actually seen an Android phone in the wild. So tell you a little bit how it works and why it's a little bit different from some of the other platforms. In terms of background on Android, I said to a couple of people before, it was actually founded by a guy called Andy Rubin in 2003 and acquired by Google in 2005. Common misconception is it was developed internally, and then open source, so given to the open source community in 2008. And the way that they've done this, the mechanism or the vehicle for that is the Open Handset Alliance. And this is the Open Handset Alliance is 47 different companies, like everything from the mobile operators, the chipset manufacturers, the commercialization experts, and of course Google, who have come together to, to sort of throw all their resources at it and create this open platform. So what originally drew me to it was the fact that, with all these guys putting these resources into it, then at some point it's going to be part of the mobile landscape going forward. So just for those people in the room who aren't really familiar or don't have sort of the background on mobile specifically, I just wanted to quickly go through a couple of things. So the first sort of style of application is the one where it was either written in native code. So this means it was either in C or C++. Now, and this is in fact what we were talking about with Armin before. You have to have a really good understanding of the hardware specifics. So you actually need to know what the hardware is, even the device, before you can give them the software. So it's a little bit more complex, and you do need to know what the handset is. Then came along Java midlets. So Java midlets run on a Java virtual machine. So you can sort of think of it as middleware, which takes your Java source code and interprets it as bytecode, and then translate that into machine code, which then the hardware can do something with. And that virtual machine sort of handles that hardware-specific stuff for you. So the beauty of Java midlets was that it started to expand your audience. As a Java developer, you could then, in theory, write it once, and then it will run on all these different handsets. You've also got the proprietary system. So this is your iPhone and Windows Mobile. And by proprietary, I mean you've got to learn, a specific language like Objective-C. And one of the things about those systems is that they actually give more preference to applications that were developed internally than those that are developed by a third party. And in fact, there's actually parts of the SDK that only can be accessed or can't be accessed by third-party developers. So what is now happening with Android? And I said before, well, in fact, maybe I didn't say before, but Android is a mobile phone operating system, and there's no there's no phone that you can point to and say that's the Google phone or that's the Android phone. Over the next 2 years, you're actually going to see 15 to 20 different handsets, that are all running a common operating system. So you're sort of moving back towards this, where you can the distribution is going to be more there than what has been sort of before. And what they're also doing, whereas Java was a little bit more limited in the SDK, like it was good that you could, you have this distribution, but you couldn't actually get down to access some of that underlying, that hardware level stuff that, to do the graphics rendering, all that sort of thing. So when I say Android is a software stack, this is what I mean. This is the stack diagram. And it's a shame that that's, can you see that up the back, Raj? I can't really do it, but okay. Well, basically, I suppose the big picture is that if this is the hardware, if you consider this is the hardware down the bottom, and this is moving towards the applications you actually use up the top. We start just down here. It's actually built. They use a Linux kernel as a hardware abstraction layer. So this has all of your device drivers, your USB connections and Bluetooth and your process management and all that sort of thing. So they've taken Linux kernel and they've optimized it for mobile. And so they've had to add things like power management. So for example, Linux comes from a desktop environment, and they haven't had to worry about the fact that, you know, when my screen is open, I want the CPU to be on, but when my screen is closed and the screen is off, then I want my CPU, you know, to be turned off to actually save battery on the device. So they do this via a series of wait blocks, and that's just one of the optimizations that they've made to that Linux kernel. Sitting on top of that is your native libraries. So these are written in C and C++, and so there's a couple of things to point out here. They sort of do, this is the area where they do all of that lower level computational, any sort of heavy graphics rendering is all done here because it's much faster being written in C. A couple of things to point out. Android uses the WebKit open source browser, so open source project. So this is the same browser that runs Chrome, Safari, and the iPhone browser. So as a web developer, if you're writing applications in CSS, DOM, Ajax, or HTML5, the Android browser will actually support that because it uses the exact same rendering engine as those other browsers. They also use SQLite as their data persistence or storage of choice. Again, it's open source. It's got a good open source community around it, and it's free, obviously. So the other thing I was going to mention, libc is another part of that native library. So they've actually, instead of using the GNU or GNU libc, they've written their own, which is about half the size, and they've done this because that library actually gets inserted into every single process. And I'll tell you more about that later on, but they basically, again, optimize this for mobile. Sitting next to that is the Android runtime, and the Android runtime is comprised of your core Java libraries. So this has all of the basic data structures and when you want to do file accessing and all the things that you'd normally expect in a Java API. So that's why it's exposed there in blue. The other part to that, and this is one of the things that makes Android quite unique, is the Dalvik virtual machine. So I mentioned before that if you can imagine this middleware that sits there, Dalvik, and one of the things that's slightly different about Android is that an instance of the Dalvik virtual machine gets inserted into a process of every single Android application. So if you imagine that this is your APK, your Android package, sitting inside of that is your process, and every single process, I'll come back to this later on, and sitting inside of that is your instance of the Dalvik virtual machine. Now, in the past, when you had your regular JVM, you'd have one, and all of your applications would be then inside of that. But with Dalvik, each application gets its own, and there's a reason for that. Can anyone tell me the reason that they might want to do that? Security. So this is sandbox at the process level. And there's a way then, if they are sandbox at this level, there has to be then a way for them to communicate. And we'll see that later on when we talk about some of the components. So sitting on top of that is the application framework. And this has got things like your application. This is, I guess, the infrastructure, things that we can rely on to achieve a task. Like it's got all of your location-based services, your resource manager, and your package manager, which handles like all of the .dex, which is your Dalvik bytecode when it's installed onto the device. Your activity manager and your view manager. So, for example, the way that the view system works on Android is just like it would on the browser. So it's a series of views, and you can it's sitting on a stack like that. And if you want to go back, you just pop one view off the stack, and then you track backwards, just like you would in a browser. So, your view system, your application framework handles things like that. Sitting on top of that is the actual applications that ship with your phone, all the things that you would expect, like your home, your dialer, your browser, and any other third-party applications. It's not listed there, but the key point to note about that is that there's absolutely no distinction between applications made by Google or that ship with the phone, or applications that are built by third-party developers. If you want to completely replace any of Google's products and write your own, or someone that your mates built, you can do that, and they're completely comfortable with that. That's what it was fully designed for. Okay. These are just some of the libraries that I was talking about before. So that was that Java API.